Okay, so we're going to pick up on 11.7. We're going to talk about
We're not going to go over homework?
homework for what?
Okay. John, what is the homework? That explains why I didn't get it.
You didn't say anything.
Yeah.
It's like this homework is tough. Yeah, we didn't finish, so we don't actually know how to do the homework yet. Speaking of which, I know some people were supposed to meet with me today. I can't anymore unless it's after 4, because I have to substitute for someone, and so that's gonna take some time. But I figured the sooner you'd want to start studying, the better. So I'll just tell you some of the tips I was telling some of the students that came to see me already, so you sort of know how to prepare. Because I realized a lot of people they were studying wrong. Okay, so first of all, you should have done all the homework. Actually tried. You should have studied for the quizzes and actually tried to do well on them. Otherwise, the advice I'm giving you might not work as well, but it'll work anyway. So I'm assuming that you actually put the work in to get this done. And so now we're going to talk about like how you actually study. Or maybe I should start more general. So well, maybe we can talk about that later. Okay, so how you would study for this class? Okay. So, assuming you did all the homework, did all the quizzes, you tried blah, blah, blah. Okay, so the first thing you're going to do, go through the review problems. First thing you're going to do is go through the review problems. A lot of people are telling me, oh, I studied by redoing the homework or by reading through my notes. That's not what you want to do first. First thing you want to do is go through the review problems. You need to complete the review problems. This is the most important part. The review problems come from the finals, and my tests look like the finals problems. Because at the end of the day, you're going to be taking a final that's worth 40% of your grade that's not going to be written by me, right? So you need to prepare for that at the end of the day, right? The final is a pretty important part of your grade, and so you want to get practice on the kinds of problems that you're going to be doing for the final, which ultimately are the kinds of problems that are going to be on my test. Except for the last one when I ask definitions. They're not going to ask you definitions on the final. But you are going to want to be able to prepare for those problems, right? That's where you have to start. The problem with going through the homework and all the notes and all blah, blah, blah is it takes too much time. You'll probably never finish studying if you do that, right? We've been going through this topic for weeks. You can't like cover that like in a week while you're doing other stuff. You just won't have the time, usually, right? I know a lot of you might work and do all that sort of stuff. The second problem with going through the homework and notes first is a lot of time the homework has these questions that are sort of testing you on a conceptual basis, whereas on a test, it's not conceptual. We're giving you a concrete problem to work out, right? So it's good that you went through the homework so you know how to think of these things. It will help your intuition, but at the end of the day, those aren't the kinds of problems that are coming on. It's not going to be conceptual. It's going to be concrete. Calculate this. Find this partial derivative, right? It's not going to be this fuzzy thing, right? So you're actually practicing in a way that's not going to help you do well on a test, especially under time conditions, okay? So the first thing you're going to want to do is you're going to want to go through the review problems. How you do that is also actually important. One, do it under timed conditions. Average time per problem on the final is 15 minutes, right? So the math department final is 2 hours and 15 minutes long. There are roughly 9 problems on it, so roughly 15 minutes per problem. It could be between 9 and 10, right? So it would be a little less than 15, but around 15 minutes. practice doing each in 10 minutes, right? So if you train yourself to get through these problems in 10 minutes, and on a final you're going to have 15 minutes, what does that mean? You can feel relaxed when you're in the final. You'll have time to look over your work when you're in the final. Double check all the mistakes that you make in the final, right? Train yourself to do each problem in 15 minutes, in 10 minutes or less, right? If it's a part of a problem, make sure you can do it in less than that, 5 minutes, right? So in some of my review problems, I'll say problem 10, part A, right? Once I say you see part A, it means on the actual final, there will be other parts of that problem with a total of 15 minutes to do it. So you need to get part A done in a lot less than 15 minutes, right? So you aim for like 5 minutes. You need time conditions. One reason time conditions is because it's actually in the test you're being timed. You want to train yourself for that. But also, and if you find 10 minutes too easy, make it less time as well. What you want to do with the time condition thing is you want to force yourself to make a mistake. You want to try to rush faster than you're comfortable thinking, right? Because what's going to happen is that's going to kind of force this artificial pressure situation like you would have on a test where you're freaking out because you're just racing and you're trying to get this done fast, and that's where you're gonna see all your mistakes start to pop out, right? If you tend to have a problem with minus signs, your signs are always wrong, it's gonna show up, right? And you're gonna know, okay, with that extra 5 minutes that I saved from here, I should go over my test and check all my signs because I know that's a weakness I have, right? So that's how you're gonna want to do it. Do it under time conditions, very important. That's where all your mistakes are going to pop up. And at the same time, you're training yourself to be comfortable with the time limit that you're going to be given. So that's what you want to do. So you go through the finals. How you're going to want to do is do all problems. So this is like 1B. Do all problems in a final in one sitting. So example, I don't remember the numbers, but let's say the review problem has spring 2010 and has problems 1, 4, 8, and then there's another one that says spring 2011 and it has 3, 7, 9, 8, etc. blah blah blah, right? See, this is a single final. You want to finish that in one sitting. Don't just practice problem 1 and then later come back and do problem 4 and 8. Get this done all at once. Get it done in under 30 minutes, right? If you don't, you're in trouble, basically, right? Do everything from a final in one sitting. Don't just pick and choose from the finals and decide, oh, I'm going to practice topic by topic. So I'm going to go through all of these and do all the problems on finding tangent planes. That's not how you're going to want to study because a test is not going to be like that. You're going to have a mixture of all different kinds of problems on a test. You want to practice being able to do a mixture of different kinds of problems. So you build up that mental flexibility of being able to switch from one topic to another in a seamless fashion and still under timed conditions, right? So you'll do everything in spring 2010. If you can also do spring 2011 in one sitting, do that as well. Here you use 10 minutes for this, 10 minutes for that, 5 minutes for that, right? So this guy, spring 2011, you need to do in one sitting. It needs to be in less than 25 minutes, right? Now, 1C. If you have trouble with a problem, well, I don't know. I'm going to put everything in step 1. Just ignore the number. The order is important. If you have trouble with a problem, then go back to the homework and notes and look at that kind of problem only, right? So if you go through this exam and you realize, you know what, problem 4 was hard for me, right? figure out what topic is problem 4. So you might read in problem 4, oh, find the tangent plane of blah, blah, blah. So you know, oh, finding tangent planes is a problem for me. Then you go back to your homework. Then you go back to the quizzes. Then you go back to the notes, and you look up that specific topic and nothing else. Kill that topic. You don't have time to be prancing around doing all sorts of stuff. Look up that topic, kill that topic. Do all the problems, redo your homework problems on finding tangent planes, or look over the notes on finding tangent planes. Rewatch the video where I talked about finding tangent planes. And then go back to your original plan. Right? 1D. It's very important that you pretend during the test. Okay, so if you get stuck on a problem, so you get stuck on a problem in a test, what would you do? You move on to the next problem. Move on to the next problem. And come back to it. Right? So I'm practicing this. Problem 1, no problem. Problem 4. Oh, kind of hard for me. You sit there for 2 minutes, nothing's coming, move on to problem 8. Right? Kill problem 8 and come back to problem 4. And guess what? Sit there for the entire 30 minutes until you figure out problem 4. Don't just be like, 10 minutes kill this one, looked at that for 2 minutes, 10 minutes kill this one, 22 minutes has passed, right? You come back to this, don't just be like, okay, I give up, and then I go to sit down. No, spend the remaining 8 minutes trying to figure that out. Because if you're in a test, that's what you do. So, I can't give away 10 points on this thing. You sit there and try to figure it out, right? You need your brain to get used to thinking under pressure, to be in a situation where something catches you by surprise and you're like, I don't know how to deal with this. But if you're in a test, you'd have to figure out how to deal with it right then and there. You don't get to go home and look at your notes again. No, you have to sit in the test and figure it out. Right? So you need to do that when you're practicing, right? You need to get in that mode. You need to tell your brain, okay, when I see something that I don't understand, I don't panic. I sit there and I figure it out. Right? Yes?
Let's say, like, at the end of the 30 minutes, you say we had like 8 minutes left to look over the code because we skipped it. If by the end we didn't get it, could we add that problem to like the next set of questions and try to do it with them? Like maybe that would be helpful?
I wouldn't. Like if you actually don't get it, then this part is more important.
Okay.
I would also probably suggest asking someone else, going to tutoring or asking a friend of yours that knows how to do it or something similar.
Okay.
Because sometimes what will happen is you'll get stuck on a problem, you won't understand how to do it, and you sit there forever trying to figure it out, and you can't. You read all the notes, you looked at all the examples, and for some reason you still can't get it. What that means is that you're looking at it wrong. You have the wrong perspective in some sense.
Okay.
And so when you go to someone, they can actually explain the notes to you. They can say, okay, how are you trying to do it? Well, this is what I was trying to do, blah, blah, blah. And then they can tell you, no, that's not the way you want to think about it, right? This sentence in the notes means this, right? Think about it this way, right? So that's how you're going to want to approach that. So if you actually get stuck on something, try to get it from your notes because you want to train your brain to try to figure out things you don't understand. After trying that, because you don't have time, you have other classes to do, go talk to somebody, right? Someone who knows how to do it, and they can tell you, oh, your thinking is wrong in this way, or it's not efficient to think of it this way, and so on and so forth. So move on, come back to it. Try to figure out that problem. Until time runs out. Don't cut the study session short. If you know you have 30 minutes budgeted for this and something's giving you a problem, sit there the 30 minutes. If you get it all done in less than 30 minutes, great. Move on to the next final, right? If you get stuck on a problem, Make sure you go back to the notes, finish that problem, then move on to the next final, right? That's how you're going to want to study, right? So you're going to want to be able to do everything in one sitting, do it under time conditions. That's going to put you under pressure. That's going to show you what mistakes you normally make. And if you get stuck on a problem, move on, come back to it, sit there for the allotted time, figure it out. What else do I want to that's basically it. Any other questions? Any questions? Anything that was giving you trouble? Yeah.
So, since there's no solutions for the problems, we just have to ask each other for help in that sense?
Yeah, Wolfram Alpha will have the answers a lot of the time. Wolfram Alpha can do partial derivatives. It can find maximums and minimums, all that. So you can even use a computer algebra system, probably get the solutions manual, practice some problems from the homework. So if you're practicing, if you realize you have trouble and you go back to the homework, then the answers would be there if you're doing odd problems. Or you can get a solutions manual to look at the even problems, so on and so forth. Or yeah, go to the tutoring center and ask questions, especially if something you're not sure about. Another thing that could happen is, especially when you're not sure, sometimes you might be doing something in an inefficient way, and so going to talk to someone, they'll tell you, yeah, you got the right answer, but you took twice as long as you should have. You know, it's better to do it this way. And so that's probably why you're not sure. You probably wouldn't do things the best way they can be done. So in that sense, again, it's also important to go to tutoring. As far as the direction you want to think in, I mean, students complain about how I set things up all the time, but there's a method to the madness. There's actually nothing I do in this class or in the syllabus that's random. So, you know, the fact that my quizzes don't have partial credit, that's not a random decision. The fact that I will take all the points on a quiz if you have a minus sign on a quiz, that's not random. The fact that I ask you definitions on all the quizzes, right? Just tell me the general formula for this, that's not random, right? That's where you go. To know the general formulas and definition, that's where you go when you have trouble, right? So I have this question, it's asking me for a tangent plane. I don't really know what to do. What do? You think about the definition. What does a tangent plane look like? What are the pieces in the formula, right? So you look at a tangent plane, and you know, well, it's a plane. The coefficients of x, y, and z must be the normal vector. How do I get a normal vector in a tangent plane? Oh, from the gradient. How do I find the gradient? Oh, I take the partials of each component. And just by knowing that, knowing what the definition says, you literally just follow your nose, right? So you're like, I don't know how to find a tangent plane, but then you think of the definition. Oh, it has this form. The first, this is f sub x, that's f sub y, f sub z. I should probably find the partials, right? Just by going back to the definition, it gives you a way to dig yourself out of a hole, right? I know a lot of people, they just drill through problems and they just sort of intuitively get how to do things. That's not how you're going to want to do it. Intuition gets you in trouble a lot of the times. If you're stuck on something, go back to the definition. It tells you exactly what you need to do, right? That's why I ask you about definitions all the time, why I ask you about formulas, right? So that, you know, you don't write down the equation of a line when I ask you for a plane because you know the definition for a plane. It's not supposed to look like that, right? So that's also important. Yeah, if you look at my quiz, it sort of tells you how the sort of things you should know in order to study efficiently, right? So if you claim that you studied about tangent planes and I ask you what the formula is and you can't write it down, you don't know enough about tangent planes, right? People often tell you, well, I understand it, but I don't really know how to write it down. You don't understand it. You're kidding yourself. I'm telling you honestly. If you can't write down something that you understand, you don't understand it. That's what it means. It means you're going to go on a test, you're going to mess up, and then you're going to look back, I can't believe I made such a silly mistake. You didn't know it in the first place because you couldn't write it down. That's how I say for this class. If you practice the habits that I try to teach on the quizzes without complaining, you should be good in pretty much any math class. But in particular for this class, this is how you would study. One thing you want to know though I guess, about college in general, or about classes in general, about life in general, is that there are many ways to describe life, but one of the best ways to describe life is competition. Life is about competition, right? You're always competing against something no matter what, right? It helps to be in that frame of mind when you're attacking something, right? There's a phrase, attacking something, that you want to conquer, a challenge that you have to overcome. You want to think of it as a competition, right? A battle, you know? This isn't just you in a math class. You're having a battle against a test. You're having a battle against me, right? So I'm like your sensei and we're sparring, right? You're in competition with me. You got to figure out, oh, you know, Jhevon always does that right hook. I need to look out for that. You know, it's a competition. You need to understand, hey, Jhevon always asks me about formulas in this class. Guess what you should study? The formulas. You're like, you know what? I have had 7 quizzes. Every single quiz in problem 1, he asked me about a formula. What do you think you need to study for quiz 8? The formulas, right? Because it's a competition. You're in an opponent, right? When you're in a competition, you have to strategize. You have to sort of figure out, what does my opponent do, right? That's why I gave you, for your review problems, again, it's not an accident that I asked you about old finals, because that's what you're going to face at the end of the semester. You need to know how your opponent behaves, right? I know this is the kind of problem that's going to come at me, right? I need to be prepared for it, right? You don't just waltz into the final, well, I kind of studied, I read over my notes. No, you're not gonna come out of that competition well, right? You have to study as how you are going to face this opponent. You got to know what he's coming with, and you got to prepare for that, right? So it's like everything, competition. That's how you want to think of it, okay? So it's like Sun Tzu said in The Art of War, which everyone should read, by the way, right? So what did he say about knowing yourself and your enemy? Does anyone know what he said? Forgot. Right? He said if you know yourself and you know your enemy, you need not fear the outcome of 1,000 battles, right? You can go into battle confident. You don't have to worry about the outcome, right?
Who said that?
Sun Tzu, in The Art of War, right? If you know yourself but you don't know your enemy, then every battle you gain a victory, you'll also suffer a defeat, right? So you lose half your battles, right? So you go from an A to a C now, right? If you don't know yourself, neither your enemy, then you will fall in every battle, right? That means when you're studying, if you think of it as a battle, what do you have to do? You have to know yourself, you have to know your enemy. The enemy is the final exam. You know how he behaves. You know what kind of questions he's going to throw at you. Prepare for it. You need to know yourself, right? So here I'm telling you, oh, just study the formulas. You need to know, how do I learn formulas? Do I need flashcards? Do I need, right? You need to know how you learn. You need to know yourself. You need to know your enemy. You need to come up with a strategy to defeat that enemy. The enemy is not going to ask you fuzzy questions. Going over the homework then is pointless. You need to go after the concrete meat and potato questions, because that's what he's going to ask you. That's where you start, because that's what he's throwing at you. You prepare for that first, right? And you got to learn how you learn so that you know how to prepare for this. You have to know what's coming, and you need to know, how do I personally prepare for this kind of attack, right? So that's how you're going to want to think of it. And I just gave you pretty much the blueprint of how to attack things in this class. Because I'm going to ask you problems that look like a final. I'm going to give you under timed conditions, so guess how you're going to study? Practice the kind of problems on the final, do it under timed conditions. Right? Simulate the battle. You got to spar, right? Because you can't be like, the first time you go into battle is the first time you throw a punch. It's not going to end well, right? Right? Well, I sort of read in a book. I read the notes on how to throw a punch. Okay, yeah, go into a fight now. Great. I'm glad you read how to throw a punch. Awesome. Okay, yeah, it's going to go very well for you when you go into a fight. No, you got to throw punches before you get into the fight, right? Don't just be like, yeah. No, do it under time conditions. Do the problems how they're going to show up. Okay. So when you're studying now, for those of you who are starting to study, that's how you're going to want to do it. Don't go over your homework and notes. That's secondary. Do that only when necessary. You don't have time, and it's not going to help as much. It's not efficient. Anyway, moving on, 10.7, 11.7. So for those of you who want to meet with me, if you can do it after 4 today, that will probably be okay. I should be free between 4 and 6. I teach another class at 6. Otherwise, it has to be like tomorrow or Monday or Tuesday. I should be pretty available. Anyway, let's move on. See if we can finish this today. Okay, so we spoke about how to find critical points. How do we find critical points? The first partial derivatives. Set them both equal to 0, solve simultaneously. Right? How do you classify them? You use that formula, right? D. Right? So we did that. Let's do some more examples of that. Because those are the kinds of problems that are going to come on a final. Let's know how to kill them. Find and classify critical points. We already did one example. This was part B. F of xy equals x squared y squared. So now we know that we're going to have to classify it, so I know I'm going to need the second partials eventually. I just get into derivative mode and find all the derivatives I need, right? So I know I'm going to need the fx, I'm going to need the fy, I'm going to need the fxx, I'm going to need the fyy, I'm going to need the fxy. Partial with respect to x?
2xy squared.
Partial with respect to y?
2y squared.
Partial squared. Right, to differentiate this with respect to x.
And 2x squared.
4xy. Right, you can either differentiate this with respect to y or that with respect to x. You'll get the same answer because they're continuous functions. Clairaut's theorem tells us those will be the same. So I'm given this find and classify all critical points. I find all these derivatives first. Right? So now what are we going to do? Set them equal to 0. So 2xy squared must be equal to 0. And I need 2yx squared equal to 0. Okay, how do I solve that? So from this, you have x equals 0 or y equals 0. If you plug in the first case, if x equals 0, what happens here? You just get 0 equals 0. Y can be anything. Or if y equals 0, you get again 0 equals 0. X can be anything. What does that mean about this critical point? The two axes, right? There are an infinite number of critical points here, right? So your x can be 0 and your y can range to be anything. And or your y has to be 0, your x can be ranged to be anything. So it's sort of like any point on the axes will work, right? So yeah, 0 comma y or 0 comma x are all critical points.
What would it be x?
X comma 0. So how do you classify any one of these? For example, the origin is 1, right? Or the point 0 comma 1 is also a critical point. How do you classify these?
Use the second derivative
So d is equal to
Okay, so let's look at points of the form 0y. D is going to be what? fxx, fyy minus fxy. So what's fxx if x is 0? It's just going to be 2y squared, right? What's fyy if x is 0? 0, right? X is 0. So this is 0. Minus what's fxy if x is 0?
0.
It's also 0. So you notice that your d is 0. So this is inconclusive. Could I actually tell what kind of points these are, though? You can. Think about it. So the test is inconclusive. How do I figure out what kind of critical point these are?
Oh, by visualizing the function?
Okay, what can you tell me about that function?
Does it have to do with anything with symmetry?
Is it like
It has to be positive.
Hmm? F is greater than or equal to 0. Right? Because it's squares. It'll never give you a negative value. 0 is the smallest value we'll ever give you, right? Now, assuming you're on the axis, on one or the other axis, what's the value it's going to give you? It's going to give you 0. If you're on the y-axis, your x is 0. If you're on the x-axis, your y is 0. So any point on the axis, this function outputs 0. But 0 is actually the smallest value that will output. So what does this mean? All critical points are minimums. Right? Because it has to be 0 or bigger, and all the critical points will give you 0. Right? So that's one way you can look into this problem. Checking x comma 0 gives same results.
Will we be extracting the thing abstractly like that on the
Very rarely. Very rarely.
Systematic, right?
Huh?
It'd be more like systematic.
Yeah, it'll be a lot more like the other one where you actually test this and you get a number and you have to compare it. Some people were asking me last time about, yeah?
When you say rarely, there's like a slight chance that it could be. But the slightest.
3% chance, 5% chance?
Yeah, well.
Yeah, you're screw this. Yeah, but
If we got
yeah, there's a you'll definitely get this kind of problem. But if this kind of problem does come, it'll be more like problem A, where you actually get D is a value, fxx is a value, and you compare them.
Just to make sure, it came out as inconclusive, so is that why you say?
Yeah, so this came out as inconclusive, means this test doesn't tell me anything. So
Right.
then I have to think about the function itself, right?
So that you set the function you set the function at 0 to get at?
No, I noticed the function was a product of squares.
Right,
Each square is 0 or bigger.
okay.
So the product has to be 0 or bigger. So I know 0 is the minimum value of that function.
Right.
And if I'm on either axis, 0 is going to be the output I get, which means it has to be smaller than any other values. Right? Once x and y move from 0, whether they move to positive or negative numbers, the output is going to be positive. It's going to be bigger. So once I step off the axis, I'm moving up. Right?
Alright.
So it means once I'm on the axis, I will actually be the minimum value. That's how I know it's minimum. So I actually looked at the function because the D was inconclusive. Okay, let's look at another one. Part C. F of xy is equal to this function. X cubed minus 2y squared minus 2y to the fourth plus 3x squared y. What's the first thing I do?
I have a partial.
Another thing I probably should have mentioned earlier. We're under time conditions, right? So efficiency is important, which means when you're attacking a problem, you need to have a system, right? Everything requires a strategy. Everything is a battle, right? So you just know when I'm classifying critical points, the first thing I do is this. The second thing I do is this. The third thing I do is this. You always have a sequence of steps that you go through, right? Everything in math has a sequence of steps on it, right? Things like this are going to be like super important in a class like 392 because there are going to be things that look really similar but are actually quite different, and you need to know what sequence of steps goes with one thing as opposed to another thing, otherwise you get confused. And it also puts you in a mode where there's like a knee-jerk reaction, you know, there's like, find and classify critical points. Your brain automatically goes to, I need to find the partials. There's no time wasted in you thinking that, because when you're doing all the practice problems, you always did that, right? You get into a habit, right? Brains like habits, right? Things that you eventually do without thinking about. Anyway, so I'm in find and classify critical points. The first thing I'd always do is find all my partials, right? So it's like if I go on an exam, I can't feel stuck when approaching a problem like this, because once I see find and classify critical points, I automatically go, oh, I need to find the partials. I immediately know what it is I have to do, right? Okay, so now what's the partial with respect to x? 3x squared plus 6xy, partial with respect to y, minus 4y, minus 8y cubed, plus 3x squared, 6x plus 6y, this one, this one is 6x. Okay. So personally, I would have differentiated this with respect to y as opposed to differentiating that with respect to x, because this one's easier. Okay. So now I know all those guys. So what do I need to do? What's the next step? So step one was to find the partials. The next step is to set the first derivatives equal to 0. So that's 3x squared plus 6xy equals 0. And I have minus 4y minus 8y cubed plus 3x squared equals 0. How do I solve that system?
You want to left first.
I'll worry about this one first. What do I do?
Subtract the x squared. And then get a y equal to negative x over. I mean negative 2 over x.
I'd factor it.
X equals 0 or negative 2y?
Right? So you know that x equals 0 or x equals minus 2y. Right? So I'm going to plug in each here. Right? So if x equals 0 over here, what happens? I get minus 4y minus 8y cubed equals 0. How do I solve that? Factor again. So I can factor out a minus 4y. I have 1 plus 2y squared.
The right side gives you imaginary.
Right. This guy you reject. That's never 0. This means that y equals 0. Right? So you get one critical point here. 0, 0 is one of the critical points. Okay? Now in the second situation, so now if my x is actually minus 2y, what does this become? Minus 4y minus 8y cubed, and this x I'm going to replace with minus 2y. So what is this? Minus 4y minus 8y cubed plus 12y squared, because squaring is negative. Get that. How do I solve that? Factor. So what would I factor out? I factor out minus 4y. What's the result? Well, I'm going to get a plus 1 at the end here. This guy would be 2y squared. This guy would give me what? Minus 3y. Right? So this means y equals 0, or 2y squared minus 3y plus 1 equals 0. How do I solve that? Well, my knee-jerk reaction would be to try to factor. It has to be 1 and 1. And I can put a minus minus. This gives me minus y, minus 2y, minus 3y. So I get y is equal to a half, or y is equal to 1. Right? So if y equals 0, what is my x? It's also 0. So this is 0, 0. I already knew that guy. If y equals a half, what is x? Just plug it in a half here. X would be minus 1. So minus 1 comma a half is the next critical point. What if y equals 1? Plug this in here. X is negative 2. So negative 2 comma 1 is another critical point. So this function actually has 3 critical points. Blah, blah, blah. Now we have to classify them. I'll leave the origin for last because you'll see why. So let's classify this guy. How do I classify it? D. D is equal to fxx, fyy, minus fxy squared. Now, at this point, what is fxx? Well, I just plug those points into fxx, and what would I obtain? Come again? Minus 3? And if I plug those points into fyy, what do I obtain? It's negative 2. What about in fxy? Okay, so what is that? Greater than 0 or less than 0?
Less than 0.
It's less than 0. What does that mean about this point?
Saddle point.
It's a saddle point. So that's a part of my answer. Now let's check the other one. Minus 2 comma 1. My d is equal to fxx, fyy, minus fxy. All right, on the formula every time I'm going to do it so that I remember it. It becomes a knee-jerk reaction, and I always forget it. fxx at this point. I'm going to take your word for that. fyy,
Negative 28.
minus 28. fxy,
Negative 12.
minus 12 squared. Positive or negative?
Positive.
Okay, so if d is positive, what do I have to check now?
Fxx.
So now I just look at fxx.
And that's negative.
Also, fxx, it's negative 6, so I know it's negative. This means, what about this point? Is a local maximum. Okay, finally, let's look at the origin. This one's kind of tricky. D, fxx, fyy, fxy squared. fxx when x is 0, x and y are 0.
Everything is right.
Everything was 0. And this this was also 0. So your d is 0, which means test inconclusive. Can we actually figure out what it is though? This will be a nice final problem, right? You have 3 critical points. 2 are the straightforward way, so the average cookie cutter math student should be able to get that. And then they put this one to find out who the A+ students are. How do you deal with that situation? Because if you know what that function looks like, power to you, because I don't. All right, so this is our function, fxy equals x cubed minus 2y squared minus 2y to the fourth plus 3x squared y. So it's not one of those things where you can say, oh, well, obviously if you're not at the origin, it's positive, right? Because that's not true. Any ideas? Hmm?
And you could like factor in the same way, so you have like x squared parentheses x plus 3y, something like that.
Okay. Factoring seems like a nice approach. So in factoring, anything stands out to you? Like when you're factoring, what's the first thing you look for?
Group.
The highest order.
No.
The common.
Common terms. Is there any common term here?
Yeah. No.
No. There's almost one though. There's a y in these three, there's none in this one. Okay. So how I probably look at this is kind of do a limit approach, set y equals 0 and sort of approach the origin and sort of see what you're getting, right? If your y is actually 0, which kills all these terms, what does your function look like? F is going to behave like x cubed, right? Now as you hit the origin, what does the function x cubed do? Does it have a maximum? Does it have a minimum?
No, so there's saddle point. Or no, it doesn't have to be.
Doesn't have to be a saddle point. There's an inflection point, right? You know that as you move to the origin, that's how your thing is going to behave. It's definitely not a max, not a min. So, right? In fact, it's not an extrema. Right? Because the thing is, if you made x equals 0 and looked at this guy, that's an even function. So it looks like a minimum. So you know it's not a saddle. Because looking at it from the other point of view, it doesn't behave the same. And saddle actually, in a plane, it wouldn't look like that in the first place. So, yeah.
What would it look like? What would it look like?
Well, in like the x, it would look like, it would be like that. It would be a minimum from one point of view, and then a maximum from another point of view.
But doesn't-
That's neither.
The point of views don't necessarily have to line up with the x or y view, right?
No, not necessarily. For this one, for this case, it does. Here. Let's look at K for time. So now, so those are all the examples. Example A and C would be the ones I focus on, because they're more like the kind you will see on the final. You know how to find maxes, mins. So you might have seen problems like this in your homework, optimization, where they try to maximize or minimize something. Now that we know how to take derivatives and find maximums and minimums, we can do this kind of problem. I'm skipping the examples though. One is pretty much the same method as you would have done in Calc 1. Except now you're dealing with multivariable functions, so there's really nothing new to tell you. 2, I've never seen it on the final.
You just jinxed it.
If it does show up on a final, I'll tell you guys about it and we'll do it then. But there are problems on your homework, so I do want you to practice it just in case, worst case scenario.
Final. It's definitely on final.
But I wouldn't really worry too much about it.
So I got to it.
Because you know how to do optimization. How do you do optimization? What's the steps for optimization?
Try to make one function out of all you're given.
No. Not really. I really want to talk about is absolute maximum. Steps in optimization. First thing, draw a diagram if possible. Second thing, you need to find two functions. One's called the objective function, the other's called the constraint function. Objective describes what you want to maximize or minimize. The constraint describes the restriction that you're given. Solve for one variable in your constraint, plug into the objective, differentiate, find the maximum or minimum, then answer the question. Those are the steps in an optimization problem. So let's move on. That's Calc 1. Look it up. Right, in the calc book, it will tell you those steps. So like I know that I can never get stuck in an optimization problem because I know exactly what I have to do when I have to do it.
So,
Okay.
just to check, should we look over the version that's in the first chapters that talk about in the book, or can we
Yeah.
just look at the same chapter and it'll talk about it?
I think they gave an example in the textbook, but it's to your benefit to look over it in the Calc 1 case.
Okay.
You can use only what you know from Calc 1 to do this. The only thing that's different between the Calc 3 case and the Calc 1 case is the differentiation stage, because now you're doing partial derivatives. Oh, we already actually reviewed how to do this in Calc 1, right? So you find all the critical points that are in the domain that you're looking at, and then you also test the endpoints. The largest value is the absolute max, the smallest value is the absolute min. Okay. So one thing you have to remember about absolute max and min from Calc 1 that still applies here is that we don't care about local max and mins. Okay. So what does that mean? In terms of efficiency, because we're being timed. You don't need the second partials, so don't waste your time finding those. You don't need the function d. Right? So you're reading a final, it says, find the critical points and classify them. You have to find all the partial derivatives. There are going to be 5 of them that you have to find. You just jump into that step. If they ask about finding the absolute max and min, you only need the first partials. You only need to know it's a critical point. You don't care, essentially, if it's a local max or min, right? So that tells you when you're facing this kind of problem, you can cut down your work, right? And you should know you can cut down your work, right? Don't just go and find all the partials like mindlessly, right? There's a strategy for this kind of problem. Okay. So we don't care about this. So let's actually see how it's done. We already reviewed Calc 1, so let's look at it here. The idea is the same as Calc 1, except now our endpoints are boundaries. there's actually another reason why I reviewed how to do it in Calc 1. On the boundary, we find the absolute max min exactly as we would in Calc 1. Right, so there was a two-pronged approach in me reminding you how to do it in Calc 1, both on a conceptual level and on an actual level. You're actually going to have to do it when you're on the boundary. Right? You're going to do exactly what you would have done in Calc 1. Let's see an example. Oh, well, let me tell you the summary. I have that written here before the examples. Someone was also telling me that they study using flashcards. If you're studying using flashcards, these are the kinds of things I'd write on flashcards. The sequence of steps to attack a certain problem. Right? Writing down a specific problem on a flashcard and trying to figure out how to do it doesn't work. It's not very efficient. But like the steps for how to do something, that you should know. Like you should know absolute max and min problem, you should be able to recite in your head the steps on how to do it. Right? Just as how I could recite what to do in an optimization problem. You should be able to do that for every kind of problem. Right? You put that on a flashcard, read it while you're on the subway. Right? So the steps here, it's on a closed boundary. Step 1. Find all critical, evaluate f at all critical points on the boundary. Step 2. Find the absolute max min on the boundary. This part is the same as in Calc 1, and we'll see how to do it. And 3, let me write 3 over here. Compare. That's your sequence of steps. Write that on a flashcard, or however you can do it. Make sure it's memorized. Make sure it's a part of you. Just like you know your name, know these steps. If I ask you your name, you spend no time thinking about it. You just tell me your name, right? Okay. Let's do an example. Find the absolute max min of, here's our function, fxy equals 4x plus 6y minus x squared minus y squared. So in these problems, they always have to give you a boundary. It has to be given, right? Just like in Calc 1, they had to give you an interval, right? So here they're going to tell you it's on the boundary D, which is the set of all points such that x is between 0 and 4, and y is between 0 and 5. You could, if you want, put a step 0 here, draw the boundary. It'll help you later on to be more efficient with what you have to do so you can actually see it. What does the boundary look like here? What does that boundary look like? It's a rectangle, right? The x goes between 0 and 4. Y goes between 0 and 5. It's a rectangle. In particular, what does that mean for you? There are 4 boundaries to consider, right? It's not an interval. There aren't just 2 now. There can be more. There are 4 boundaries we have to consider, right? So there's boundary 1, boundary 2, boundary 3, boundary 4, right? So in step 2, there are going to be 4 things, 4 functions that I have to look at. Okay, so that's going to be the situation. Now, I need to remember that in part 1, when I find the critical points, I need to make sure they fall in this, right? This is D here. Well, technically that's not D, that's R. D is the surrounding. Right, D1, D2, D3, D4. Okay. So step 1, find critical points. Remember, I don't care about classifying them, so I only need to worry about the first partial derivatives. Partial with respect to x is what? 4 minus 2x, partial with respect to y. 6 minus 2y. So, for critical points, I need 4 minus 2x equals 0, and 6 minus 2y equals 0. This means x equals what? This means y equals what?
3.
So that means 2, 3 is the only critical point. Is 2, 3 in this guy? Yes, 2 would be here, 3 would be here, so 2, 3 is going to be somewhere in the middle. So this is a point that we actually care about, evaluate it there. So we need to find f of 2, comma 3. 3 is in D, so find f of 2 comma 3. In this case, it's going to be what? What's 2 comma 3 here? 13. 2. Now we're going to test the boundaries. This tends to be the annoying part of this kind of problem. Testing the boundaries. Straightforward, but it can still be annoying. Now remember, from drawing my picture, I know there are 4 boundaries that I have to test. Right? So let's look at D1. So here's the trick with testing the boundaries. We need to know an equation that describes the boundaries, right? The boundaries are curves. Means I should be able to figure out an equation that describes it. So D1, what's the equation for D1? Y equals 0 is the equation for D1. Now what you do then is you literally go back to the original function and you plug in y equals 0. Right? So you define a new function in terms of x. Define g of x to be f of x comma 0. Replace all the y's with 0. And what's the function we get? 4x minus x squared. Right? On what's the interval according to x?
0 to 4.
On 0 to 4. So now, pretend you're in calc 1. They actually find the absolute max of this on this interval. Do exactly what you would do in calc 1. What would you do in calc 1? You'd find g prime. Right? You set that equals 0 for critical points. which means my x is 2. Right? So I already know that 2 coincides with 2 comma 3. I already checked that, right? When my x value is 2, I know my y value is 3. I already did that. So nothing to test there. But what about on the boundaries? So I know that g of 2 is actually equal to 13 because g of 2 is just f of 2 comma 3. But what else do I have to check? I have to check g of 0, right? Because 0 is one of the endpoints here. G of 0, I plug into here, is just 4. G of 0 actually corresponds to f of 0, 0. Because now my x is 0 and my y is 0.
Wait, I'm sorry, wouldn't G of 2 be f of 2 comma 0?
G of 2 would
I thought
be...
G was equal-
Oh, this is 0, yes.
Okay,
2 comma 0, which is... We plug it into this function.
yeah, so it's, it's 4.
It's actually going to be 4. Right. So this is not 2. Right, so at this point you sort of forget everything you did. You just pretend this is a new problem now in Calc 1. Find absolute max on this. And what else do we need to find here? G evaluated at 4. G of 4, which is equal to f of 4 comma 0, because all my y values are 0, will be I just plug in 4 here,
It's 0.
and I get 0. Right? So far I have 1, 2, 3 values. So far this is the biggest one, but let's see if he stays the biggest one. You're going to have to do it 4 times. Now you look at D2. So on D2 is the line x equals 4. So you describe this as x equals 4, which means you're going to define a new function, g of y, which is f of 4 comma y. So you go here, you plug in x equals 4, what do you get? These two will just kill each other, so you actually end up with 6y minus y squared on, now I look at the y interval, 0, 5. So go back in Calc 1 mode, find g prime. So y equals 3 for critical point. And this would be 3 comma, so now I check f of 4 comma 3. Is that actually in my region? Yes. So I pretty much plug in 3 into this for y. If I plug in 3 here, what do I get? 18 minus 9. I also have to test the boundaries. So I need to check g of 0, which is just f of 4 comma 0. I also need to check g of 5, which is f of 4 comma 5. So in g of 0, I just plug into here. The result is 0. G of 5, I plug 5 into here. 5 times 6 is 30 minus 25, that's 5. Move on to the third boundary. The third boundary is what equation? What?
Y equals 5.
Y equals 5. So I defined a new function, g of x, which is just f where I replace the y with 5. Okay, erase my function. What if I replace y with 5 in the original? What did I get?
4x minus x squared minus 5.
I get minus 5.
Sorry, plus 5.
It would be a plus 5. Okay. So now, what do? I find G prime. G prime would be
4 minus 2.
4 minus 2x, which means x equals 2 for critical point. My x is 2 and my y is 5, so I'm going to check g of 2, which is just f of 2 comma 5, which is still in my region. So what do I get here? I just plug in 2 for x here. So what do I get? I also need to check the endpoints. This is on 0, 4. So I check g of 0, which happens to be f of 0, 5, which is, I just plug in 0 here. G of 4. This means f of 4 comma 5, which means I plug in 4 into here. I again get 5. That's everybody. One last region to check, D4. And in case you're wondering, did they actually give us such a long problem on a final? Yeah, this is actually a fair final problem. If they give you less than 4 boundaries to check, you can best believe that the functions are going to be complicated. So they'll catch you one way or another. They make these problems complicated. Because they're like, oh, this part is just calc 1. And so all the higher ups think, oh, they should have no problem with this. So they try to make it harder. So on D4 was the line x equals 0. So I'm going to define a new function of y, which is just f of 0 comma y, which is going to be, what was that, 6y minus y squared. And again, it's on the y interval, so it's 0 to 5. And so now I find g prime, 6 minus 2y, which means y equals 3 for a critical point. So I'm going to test the critical point. G of 3 is actually f of 0 comma 3, which is still in my region, which means I just plug in 3 into here. I get 5. No, 5 is into there gives you 5. But I plug in 3 into here. 3 6 is 18 minus 9, so I get 9. That's the endpoints. G of 0, just plug in 0 here. G of 0 gives me 0, 0. And I test G of 5, which is going to be f of 0, 5. Plug in 5 here, I get 5. Okay.
In the right over there, no, like you did before, where you have where you still you're doing the first line where your y is equal to 0.
Yeah.
Over on the right.
D1?
Yeah.
Like 4, yeah. When you did g of 2, well, no, sorry, g of 0, you said it's 4. Isn't g of 0, 0? When you plug it back into the original function, 4x minus x squared.
G of 0. No, G of 0, it's plugged into this function.
Yeah. 0, 0. I think you plugged it into g prime if that's not accident.
Well, I was listening to you guys. Yeah, well, that should actually be, you're plugged into this one. And so this is, okay. So now what? We tested all the boundaries, right? So now we should be able to make a conclusion. Make sure you get that stuff. So what's our conclusion? We tested a bunch of things. We got 13, 4, 0, 0, 9, 0, 5.
So the absolute max would be 13.
Absolute max is obviously the 13. Right? So absolute max is f of 2 comma 3, which is 13. Absolute min?
It's a couple.
What's the absolute min so far? Was it 0?
Yeah.
Alright, so this is f of, what are all the guys that gave me 0?
0,
f of
0,
0, 0,
4, 0.
f of 4, 0.
Just those two.
Just those two equals 0. So that would be your ultimate conclusion. Okay, so I know it's a lot to digest if you saw it for the first time and I actually erased it, a part of it. So let's go over the steps again. I'm given a function and I'm told to find the absolute max and min, right? Which means I don't care about the second partials, but I need the first partials, right? So I'm given that function which I erased. The first thing you're going to want to do is find the first partials and find the critical points by setting each equal to 0, solving simultaneously. Double check that that point you get is actually in the original described boundary, right? If it's in there, evaluate the function there. If it's not, ignore it, right? Then you move on to all the boundaries. Now you're going to need to know what all the boundaries are, so I would suggest that you actually draw a picture of it, right? Because you're going to need the equations for each curve on the boundary. And basically what you're doing is when you're testing the boundaries, you're actually plugging in the equations for that curve into the original function to get a new function. Now what's going to happen is that new function will always be in a single variable, right? It will always be only purely a function of x or purely a function of y. So you get the intervals for x and y, and you just do it like a calc 1 problem. Find the absolute max and min on that, right? You're going to test a bunch of points, and you do that for every single boundary. And at the end of the day, you're going to compare them. Look through what you did, find the largest value, that's your absolute max. Find the smallest value, that's your absolute min.
I have a question. I noticed that for each one, you kind of like switched around. Like you did y equals 0, and you did x equals 4, y equals 5, x 0.
That's coincidental.
That's coincidental?
Yeah.
So
I based it on the equations of my curves. It really doesn't matter which one I did in what order.
Oh, okay.
I have to test all the boundaries anyway, so it doesn't matter which one I do. They're not, one is not dependent on the other. You think of each little part here, testing a boundary, as a problem unto itself until you get to the final conclusion. Then you have to look at everybody.
So we could have easily done x. For D1, I guess.
You could have called it D4, it doesn't matter. It doesn't matter when you do it.
No, what I mean, like, because you set your values for y equals 0, that's from, like, the graph we made.
That was the actual equation of the graph.
Yeah, oh.
So if D, it could be, for example, they could give you the boundary that's like, it's a part of x, y equals x squared and then y equals 4. In which case I'd have two boundaries, D1 and D2. In which case D2 I would use y equals 4 and D1 I would use y equals x squared. And so what I would do is I would go to the original function and everywhere I see a y, I would replace with an x squared.
Okay.
I get a function purely of x and I do the calc 1 absolute max and min on that.
Okay.
And then I plug in 4 into the original function. I'll get a function, again, purely of x, and do the calc 1 absolute max and min on that. So it depends on what the curves you're given. Like, they'll tell you what the curves are. They have to give you that boundary. And you plug that into the original function, it will reduce it to a single variable problem.
All right.
So for the absolute minimum, there was like a bunch of coordinates that equal 0. We have to put all of those coordinates?
Yeah.
Okay, because I think it was,
Yeah, they double up.
oh,
Yeah, some of them were repeats, which you can actually look for. So sometimes, like here, if I notice, oh, g of 0 is just f of 4 comma 0, I could have remembered, oh, and back in D1, I actually had that same point.
Oh, okay.
So I didn't actually have to recompute it. I could have just, whatever answer I got there, I just rewrite it there. So. Any other questions?
You kind of half answered it. So like if we see like a problem like that where our D1 and D2,
Yeah?
where do we have to then solve for the endpoints, or is there not really?
Yeah, you'll see the endpoints. Like here, this would actually be what for the x? This would be minus 2, and this would be positive 2. Right, so if you have a function purely of x, the interval you test is minus 2 to 2. Right, so that's the x interval that you test. If you're testing a y interval, what would you test?
0 to 4.
0 to 4.
So we have to kind of extrapolate from what we're
Right,
given.
so
find
they'll
the
tell you
intervals.
something like D is the region bounded by y equals 4 and y equals x squared. It's possible for them to describe D in that way.
Okay.
And then you have to say, oh, that would be the picture, these would be the intervals.
Okay.
It sort of wouldn't tell you.
So primarily the idea, we're just gonna have to make that box and then find the boundaries with the box.
Yeah, you find the boundary based on how they describe it to you.
Or whatever.
Like, they have to tell you this. They have to tell you what your boundary is.
Yeah.
They might not give you all the information. You might have to find the intercepts on your own, but they'll assume you know how to do that and figure out the intervals.
So just like Bill, think about it. So like you have that region, and then it like would cut up into like some curve in the z axis, and then you just have to find like whatever like the max point that we
Yeah.
point to.
Technically, what you're looking at is like a level curve. So it's
Yeah,
like
yeah.
this plane comes up and cuts your function f,
Yeah.
but then your y value becomes irrelevant because you already set the y value equals to 4. So now you have this curve in space that's going to behave like a function of x.
Yeah.
And so you look at the highest point there. Which that brings you into the calc 1 case. Once you set y equals 4, you're in calc 1 now. Because you're actually not a multivariable function anymore. You actually fixed one of the values. Other questions? Want to do another example?
Yeah, for sure.
No.
I only had one more example. Because conceptually, everything you need to know about this kind of problem was done in this example. So another example is just for variety. And of course, you'll see a bunch of these in your homework. There are also a bunch on the review problem. So by that time, you should get a lot of practicing. Find the absolute max. And then, f of xy equals sine xy. So that's the given function. And on the closed region, given by By the way, there are times when D, they could tell you it as a circle, and there are times when actually rewriting your function in terms of polar coordinates actually makes your life easier. I'm sure there are homework problems like that, so I'll have you guys think about that on your own. Let's do this example. It's actually another rectangle. So in this case, my x goes between 0 and pi. My y goes between 0 and 1. So it's just another rectangle. So what do I need here? In my partials. Fx is going to be what? Huh?
Y equals
This is the angle. And Fy is x cosine xy. So I set these guys equal to 0. And this equal to 0. So in one, this either means y equals 0 or cosine xy equals 0. If cosine xy equals 0, what does that mean?
X and X, no.
Xy must be equal to 1. Pi over 2 is one case. What are all cases? Cosine 0 at n pi over 2, where n is odd, right? So there's going to be like a pi over 2 plus or minus 3 pi over 2 plus or minus. Not all of them is going to be in this region, but you should actually just know that these are the values that will make it 0. Okay. So what will we do here? So now we go over here. If our y equals 0, what does that mean? I get x cosine 0 equals 0. Cosine 0 is what?
1.
This is 1. So I just get x equals 0, which means I get the origin as a critical point. Which I don't even care what kind of critical point it is. Here, if my x times y is a multiple of 2 pi, of pi over 2, then what does my equation become?
Y is equal to n pi.
2 x.
What?
Yeah. So n pi over 2x. No, I mean 2y.
Well, xy is this.
Yeah.
So that means I have cosine of this. So what does that mean?
Oh, yeah.
X could be anything.
X equals anything. Right? So as long as my x times y is this value, everywhere along that line, or that curve actually, right? This is just a curve, y equals n pi over 2 over x. Everywhere along that curve, it's going to be a hyperbola. I will have a critical point. How many of those are in my region? Zero, 0 is in my region. Do I know f of 0, 0? What's f of 0, 0? It's just 0, right? Because it's just sine of 0. What about these guys?
X has to be 0 to pi.
Come here.
X is equal to 0 or pi, like 2 pi. The boundary.
I know x times y must be n pi over 2, right? So it could be pi over 2, for example. Is that actually in the boundary?
Yeah.
Yeah.
Yeah, for example, if I'm at pi over 2, I could be the function 1. It'll be on the boundary here. X times y would be pi over 2. Can x times y be 3 pi over 2?
Yeah.
How?
Wait a minute.
Like if your x is 3 pi over 2, your y couldn't be 1 because that's outside. Minus pi over 2 would also be outside. What about any fraction in between?
And the n value doesn't give you that?
Yeah, I looked at for example, n equals 1. Right? It could work. Right? So it turns out that both of these would be on like the boundary. We can move on to the boundaries. Don't have a lot of time. So let's look at the boundary. D1. What's the equation for D1?
Y is equal to 0.
Y equals 0, which means my original function would be, I would define g of x to be f of x0. F of x0 is
0.
0 function, right? No absolute maximum. Right? Nothing to do. 0 is always 0. You can think of every point being an absolute maximum, but for our purposes, we'll say none. If we do D2,
I thought we would do
x equals pi. So my so I define a new function, g of x, g of y, which is f of pi comma y which would be what function? Sine of pi times y. Right? Which, if y is an integer, that'll be 0, but it's not always an integer, so let's find the critical points. G prime of y would be what?
Pi cosine pi y.
Pi cosine pi y. What interval are we on for the y? 0 to 1. So I'm going to find a critical point here. I would need my y value to be what? 1/2 or plus or minus a half. It could also be plus or minus 3/2, right? Or how many of these values will be inside our region?
Just 1/2.
Just the 1/2 is the only one I care about, because all of these, the y values are not between 0 and 1. So these I wouldn't care about, and I would only test the point where y is a half and x is pi. So now I do g of my y value should be a half, which gives me f of pi comma a half, which is, I just plug in a half here, sine of pi over 2 gives me 1. Then I test the endpoints, g of 0, meaning I plug in 0 for y here, what's the value? 0. I can also test g of 1, which is just f of pi comma 1, which means I plug in 1 for y, so I get sine of pi, which is 0. Move on to D3. D3 is what curve? Y equals 1. So I define a new function of x, which is just f of x comma 1, which I just plug in y equals 1 as the original. So this is just sine x. So then I find g prime, which is cosine x, which means my x must be plus or minus pi over 2, plus or minus 3 pi over 2, so on and so forth. How many of these are inside that region?
The first one.
That's the first one, that's pi over 2, right? That's the only one I care about here. So I find g of pi over 2, which is just f of pi over 2 comma 1. Plug in pi over 2 here, sine of pi over 2 is 1. No, it's not yawn. What's my interval here? The x interval.
0 to pi.
0 and pi, which means I have to test g of 0, which would be f of 0 comma 1. So I plug in x equals 0 here, I just get 0. I also have to test g of pi, which means I plug in, this would be f of pi comma 1, which means I plug in pi here, again I get 0. Finally, we do D4, which is the equation y equals 0, x equals 0. This is x equals 0. So I define a function g of y equals f of 0 comma y, which is actually the 0 function. So no absolute maximum, because it's always 0. Absolute max in this problem is what?
1.
The biggest value was 1?
Yeah.
From where?
F of pi comma 1/2, and f of pi over 2 comma 1.
Pi comma 1/2. There was another one?
Pi over 2.
Equals f of pi over 2 comma 1 is 1. What was the smallest value? 0, right? Which guys gave me 0? 0 comma 1, 0 comma 0, pi over 0, pi 1. Was that it? Was that it?
It's also like the curves though, I mean like the line, so you got a G of Y right there. No, you say no absolute maximum, but it's 0 for everywhere, so it's like the whole line.
Yeah, the whole line is going to do that.
And also, are we missing points with absolute max? Or what if it's like x is equal to 2 and y is equal to 5 and 4?
Not in the region.
It is.
If x is equal to 2 and y is, oh,
Y is equal to the power of 4.
that would be on one of these lines. That would probably work here. So yeah, we'd have to examine this one a little bit more, but we're out of time. We'll end right there. That's sort of the idea. We're already 5 minutes over time.
Yeah.